All right, here's your third unit on adding and subtracting rational numbers. Let's go up to your table of contents. Today, we're just going to be doing learning goals 13, 14, and 15, but just focusing on adding and subtracting decimals, adding and subtracting fractions, and then evaluating expressions involving decimals and fractions. So this is 13, 14, and 15. So put in your date for today, and then go ahead and add learning goal 13, 14, and 15 on there. All right, let's go down to the actual lesson itself. Let me get rid of the page sorter there. All right, now, since we're adding and subtracting rational numbers, we know that you're going to have to follow your integer rules. And so anytime we're adding integers, that means we are singing the song. So let's record that down. And that is same signs, add and keep, different signs, subtract. Keep the sign of the bigger digit, then you'll be exact. All right, so we have, let's record that, same signs, add and keep. Or we have different signs, different signs, subtract. And then we know we need to keep the sign of the bigger digit. Then you'll be exact. All right, now we do not like subtracting integers, and so that we always know that that makes us sad, and we go to KFC to fix that issue and make us happy again, and that is doing our keep, flip, and change. Okay, or you might just start thinking about it as adding the opposite. Okay, all right. With decimals, we have two steps that we need to follow. Number one is you must line up the decimals. This is only true for addition and subtraction, not multiplication, division. Okay, and then number two is create the placeholders. So placeholder zeros. Okay, and then you'll see what I mean if you don't remember that piece there. All right, so let's go ahead and we'll talk about the fractions in a little bit. Let's head down to evaluating these decimal expressions. So your first thing that I notice is I have decimals, so I'm going to set them up here and line them up. So 8.5, and notice I'm just reading the digits so I don't make a mistake, and 0.09. And then I'm going to go ahead and put my placeholder 0 so everything's lined up. Okay. Now we need to address the addition or subtraction. So we're adding integers, which is great because it just means that I'm going to be singing my song. Okay. And so I see that they're both negative. So that's same signs, add and keep. So I'm going to be adding these two numbers. Okay. And I'm going to keep the sign. So I have my negative here. Okay. All right. Now we'll go ahead and add them up. And there we go with -8 and 59 hundredths. Let's make sure that makes sense. Check for reasonableness. I owe someone $8.50. I owe another person 9 cents. So it makes sense that I owe that as a total. Okay. All right. Over here we have subtraction. I don't like that. So right away I'm going to go to KFC and make myself feel better. Don't do that in real life. You might, eat too much KFC. So keep, flip, change. Now I notice that I have different signs, so I'm going to be subtracting. And so as I write these, I need to make sure that I put the 9.8 on top. Okay, and then I have my 8.23. Go ahead and put my placeholder 0 in. All right, so I sing my song now. Different sign, subtract. Keep the sign of the bigger digit. and the bigger digit is a negative, so I'm going to end up with a negative here. So let's go ahead and do our subtraction. I'm going to have to do a quick regroup here. And so I have 10 minus 3 is 7, and then 7 minus 2 is 5, and then 9 minus 8 is 1, okay? All right, and I have a negative 1 and 57 hundredths as my answer. Let's check for reasonableness. And so I know that this is approximately 8, this is approximately 10, and so it makes sense that different signs subtract. 10 minus 8 is 2, and so negative 2 is definitely close to that, so that makes sense, okay? All right, over to here, I have a subtraction. I don't like that, so we're going to KFC that right away. Keep, flip, change. Now I just have a nice addition problem. Approximately 4, approximately 8, so 8 plus 4 is going to be approximately 12 as my answer, so we'll see how accurate that is. We can go ahead and, because they are the same signs, we're going to be adding, so I can just go ahead and write my decimals. 8.27. Same signs, add and keep, so it's going to stay positive. Okay, 7 plus 5 is 12. 3 plus 1 is 4, plus 2 is 6. And then 8 plus 4 is 12, okay? And my answer is pretty close to my estimate, and so we're good there, okay? All right, down to number 4. Yay, addition, I get to sing my song. All right, same signs, add and keep, that's not accurate. These are different signs, so different signs subtract. So I'm going to need to write my bigger digit first, which is the 5.5. Minus the 1.25. Go ahead and put our placeholders in. Okay. Now focus on the song. Different signs subtract. Keep the sign of the bigger digit. Bigger digit was the 5.5, which was negative. Okay, so I'm going to put my negative down there right away so I don't forget. All right, we have some regrouping to do. Okay, so now I have 10 minus 5 is 5. 4 minus 2 is 2. 5 minus 1 is 4. So we have a negative 4 and 25 hundredths. Let's check for reasonableness real quick. I have approximately 1, approximately a negative 6, we'll call it. 6 minus 1 is 5, and it stays negative, so pretty close. Okay, all right. Now we're on to fractions, so we're going to have to pause what we're doing here and go back up to fractions. A couple things that we know about with fractions. Number 1, we could go ahead and change them to decimals if it's easy, okay? So we have an option here. Okay, so option 1 would be to change to decimals, okay? So if we can do that, that makes life pretty simple in the sense that we know we're doing with that. We've just done that. Option number 2 is to make a common denominator. And then you can add or subtract. But realize that sometimes you're going to want to make a common denominator with the improper fraction rather than dealing with regrouping with the whole number. So we'll take a look at what that looks like a little bit here, okay? So as I look at this problem here, I want to just start noticing things, okay? So I see that's addition of integers, so that's a, it's addition of rational numbers here. And so I'm going to be singing my song either way at the end of this, okay? I want to see if I happen to know what these are as decimals, which I don't, okay? So the next thing is I want to make a common denominator. Since I can see that this 3 can easily be turned into a 6, I'm probably just going to go ahead and do that, okay? And so we'll go ahead and we will make an equivalent fraction by multiplying by 2 over 2, okay? So I'm going to now rewrite what I have now, okay? So I have -2 and 2 6 plus +2 and 5 6, okay? All right, now the reason that we talk about making an improper fraction is because now you see we have this negative whole number and a positive whole number, and then we have our fractions and things like that. So a lot of times it's just easier to work with improper fractions. You can do this if you have a good conceptual understanding, but typically it's easiest to just change these into improper fractions. So I'm going to multiply by the whole and then add the numerator, and I end up with 6 times 2 is 12, plus 2 is -14 6, and then I have 12 negative, the 6 times 2 is 12, plus the 5 is negative, this is positive, is 17 6. So you can see that's a lot easier to manage now. And so we can see those two fractions and sing our song. So we have same signs, add and keep, not accurate, different signs, subtract. So I'm going to go ahead and do my different sign subtract. So 17 minus 14 is 3. Keep the sign of the bigger digit, and the bigger digit was positive. Okay, so we end up with a 3/6. Okay, we can simplify that by dividing by 3 over 3. Okay, and I end up with 1/2. Okay, and so here's my final answer. I'm going to go ahead and highlight that, and there we go. Okay, checking for reasonableness, I have my 2 1/3 plus a 2 5 6. Well, this is approximately 3. This is approximately 2.5. So that makes sense that the 3 minus 2.5 is about a half there. Okay. All right. Let's go ahead and look at the next one. First question is, can I change these to decimals? I mean, I guess the first thing is noticing, do they already have the same denominator? Since they don't, I'm going to be looking, can I just change these decimals real quick? I don't know what those are as decimals, so I'm not going to do that. Let's see, I could look and see, can I turn the 3 into a 7? I can't do that. So I think we're just going to go ahead and make new fractions that are common denominators. At the same time, if you want, I mean, you could just turn these to decimals by pulling out your calculator. So I'll show you both ways real quick, since this is a video and you can scan forward. So let's go ahead and first just take care of making these common denominators. It is addition, so I don't have to KFC it. And let's go ahead and solve these out. So I'm going to start thinking about my least common denominator. So I'm thinking about my multiples of 3, 3, 6, 9, 12, 15, 18. All right, so I think 21, actually using each other's number, is going to be our least common denominator. So we'll go ahead and multiply by 3 over 3, and I'll multiply by 7 over 7. Okay, and we'll create an equivalent fraction here. So I have and again, if you want to sort of rewrite these this way to make it easier, you can. It's up to you. So 3 times 1 is a -3. The 3 times -1. And we have 21sts. And then we have plus a -2 times 7 is a -14. And that is with a 21 in the denominator. So I have my new fractions, which actually makes this problem not too tricky. I am going to sing my song, same signs, add and keep. So 14 plus 3 is -17, add and keep, over 21. We're actually done with that, okay? Like I said, if you wanted, you could have changed those to decimals, but let's see. 1 divided by 7 ends up being this really, really long repeating decimal, the 0.142857, 142857. So I'm not going to do that if it's repeating. So that brings me to this point. So let's head up here, and I want you to be aware of something with the fractions, okay? So you cannot, so with fractions, you cannot change them to the decimals if they are repeating decimals, okay? So let's draw a little arrow down here. You cannot do this if the decimal is repeating. And that's because just because you can type some of it into your calculator, you're not going to be accurate when you're doing your math work. So you can only change to a decimal if it is a terminating decimal, okay? All right, let's go ahead and highlight, not erase, highlight our answer, and we'll go ahead and move on to the next problem, okay? All right, I see a subtraction, so I know that I'm going to use KFC right away. So keep, flip, and change. I have 2/3 and 8/9. 2/3 is a common decimal that you could change it to. I'm not sure what 8/9 is, but we can go ahead and check. I do see, though, that my denominator, I can easily change that thirds to a ninth. So that's pretty quick and easy for me rather than changing all the decimals and things like that. So I'll probably just do that, but let's go ahead and see what 8/9 is anyway. If we do 8 divided by 9. Okay, it's a repeating decimal anyway, so I can't do that. Okay, so what I'm going to do is go ahead and make a common denominator fraction. And so we'll multiply by 3/3, okay, because I know that will make my common denominators. And so I have a negative, again, I'm going to look at it like this, okay. I have a negative 6/9 plus, because I did my KFC, my 8/9, because that's already good, okay. All right, now I sing my song. Same signs, add and keep. Nope, don't have the same signs. Different signs, subtract. So I'm going to subtract 8 minus 6. Okay, and I get 2. Keep the sign of the bigger digit, which is the 8, the positive, and we end up with 2/9. Okay, all right, and we can't simplify that, so that is our final answer. Okay, all right. Let's go ahead over to number 8. I can see it's a subtraction. So I'm going to go ahead and quickly KFC this. Okay, now that we've done KFC, I can go ahead and think about what I want to do here. Okay, so I can't easily turn 5/6 and 3/8 into decimals. In my head anyway, but let's go ahead and see on our calculator what 5/6 is as a decimal. Okay, so it's a repeating, so I already know I can't change it to a decimal, so I'm going to have to work on it as a fraction. Because I have this giant negative 11 here as a whole number, that's just going to be a little bit annoying to deal with here, but we can go ahead and work through this. So first thing I'm going to do is try to, I'll probably just turn this into an improper fraction so I can work with it that way first. So let's go ahead and I'm going to multiply by the whole and then add the numerator. And so I get 6 times 11 is 66 plus the 5 is 71. This is all negative, so I have negative 71/6. plus a negative 3/8. And you can see visually how much easier that is to look at, okay? All right, now what we're going to have to look at and do is create a common denominator. I can't turn the 6 into an 8. I can't easily turn these into powers of 10s. I know that the 5, 6 wouldn't have done that anyway. So we're going to have to go ahead and try to come up with our least common denominator. So I'm sort of thinking through, I know I can do 6 times 8 and get the 48, but let's go ahead and see if there's anything else. So I'm sort of thinking of my multiples here a little bit. So I know 6 times 4 is 24, so that'll 24 will be a good one. So let's go ahead and make 24 as our least common denominator. So we'll go ahead and change those. So I know that 3 times 8 is 24, so we'll multiply by 3 over 3 for this one. And 6 times 4 is 24, so we'll multiply by 4 over 4 for this one. Okay, let's go ahead and get our new numbers down below. We know that they're both going to be over 24. Okay, 3 times 3 is 9, and we hate to love, so we hate, we're at negative 9 still. And then negative 71 times 4. I don't know that in my head real quick, but I'm going to go ahead and write it down. So 4 times 1 is 4, 4 times 7 is 28, and that's still negative. So we have negative 284. So here's our new problem. We go ahead and think about our song. So same signs, add and keep. So I'm going to add those up, the 284 plus 9. So I'm thinking 284, 294, one less is 293. Same signs, add and keep. So 293, keep the negative, over 24. And what's great in this class for you is you can just leave it at that. You don't have to change it back into a mixed number. You can keep it improper, okay? Now, if we want to check for reasonableness, I can sort of look at this as we're at 5, 6. We're pretty close to 12 with this one, negative 12. 3/8 is pretty close to 4/8, which is pretty close to negative 1/2. Okay, so if I'm adding those up, same signs add and keep, it would be about 12.5. The way for me to check this would be I can pull this out and type in my 293, my negative 293, and divide it by 24. When we see that it ends up at negative 12.2. So that is pretty close to the estimate that we got there, okay? All right, we have 3 more to do. You can see this takes time and focus. You're able to do it, you just have to really slow down and think about it, okay? All right, so we have a negative 21/20 minus a 0.3. I don't know what 21/20 is as a decimal, but let's go ahead and pull that calculator out. Let's see if it does make a terminating decimal. If it does, that would be nice for us, and it does. It's a 1.05. So I'm going to go ahead and use that instead, and so we have KFC, first of all, because we don't like subtraction, so adding the negative. So I have a negative 1.05, okay, plus a negative 0.3. Okay, so let's go ahead and solve that out. It's just a adding of decimals, so we know our steps are to line things up here. So I have a 1.05 and a 0.3. Put in your placeholders. Now focus on the song. Same signs, add and keep. So right away I put that in there. And I'm going to go ahead and add all those up. And there we go with a negative 1.35, or negative 1 35 hundredths. Okay. I'm going to go ahead, and we want you to be able to do this as manually as possible, but it's okay to use a calculator, even especially to like check your work a little bit, plus the 0.3 negative, and there we go. Yep, so we're good. Okay. All right, let's go ahead and look at this one. I already have a decimal, so let's go ahead and see if 2/11ths, 2 divided by 11, makes a terminating decimal. It doesn't, so we cannot do that. So we're stuck turning the decimal into a fraction. We know the easiest way to do that is to just read it and write what you say. Okay, so I read this as 0 and 15/100ths. Okay, so we still have the negative, and that's 15/100ths. Okay, so here's my new problem: -2/11ths plus -15/100ths. Now I can't turn the 11 into 100, so right away, this, if I'm being honest with you, that is sort of a pain because we already have quite a big number here that we're dealing with on the right-hand side here. So you could just multiply by each other's denominators. You're gonna with a really big number. But instead, what I'm gonna do is I'm gonna try to make this a little bit smaller so I have a smaller number to work with. And I know that I could divide by 5/5 to get a smaller number. So I'm gonna go ahead and do that because I know 5 will help us get there. So what times 5 is 15? That is 3. That's still negative. And then we have 20 times 5 gets me 100. So I made a new number here that we'll deal with, and it's at least going to make it a little easier to solve this. So I'm going to do a rewrite here. Okay, and now I can try to find at least a smaller common denominator than what we would have had. Okay, so we'll go ahead and I'm going to multiply this one by 11/11, and we'll multiply this one by 20/20, and we'll create our new numbers. Okay, and so if you don't know what 11 times 20 is, that's what your calculator is for. Okay, you could do it on the side or just get that. It's 220. Okay, and so in our denominator, you have 220 for both of these. Okay, we're adding, and then on the top, 2 times the -2 is, or 20 times 2 is 40. It's still negative. 11 times 33. 11 times 3 is 33, and that's still negative as well. So now we have our new problem. Sing your song, same signs, add and keep. So 40 plus 33, 50, 60, 73. Keep the signs, and you are left with this, -73 2/20. Okay, all right, and then over to here, let's go ahead and check this. Right away, I can see if 7/8 is a terminating decimal, which you'll know that it is soon if you don't, because it's one of our common ones that you'll be aware of, which is 0.875. Okay, so I'm going to go ahead and 0.875, rewrite my new problem, and you can see this ends up being really nice. I'm going to go ahead and put my placeholder on this one right away. It's addition, and I have the same sign, so same signs, add and keep. So I'm going to go ahead and add these up. Line up your decimals is your first step. Okay, and we're going to be keeping the sign, so it's going to stay positive. A little regroup there. And make sure you bring down your decimal that's lined up there. All right, and there we go with, wow, I keep deleting, 1 and 705 thousandths, okay, as our answer. And that makes sense because this is a little under 1 and this is a little under 1, so it makes sense that my answer is a little under 2. Okay. All right. There is your lesson. I know it's a lot of detail and a lot of thinking, but you can definitely pull it off. You just have to really slow down and think what is your best option in all those situations.